Hi, hello, and welcome to the second part of our day one schedule of 18-day action plan. In this session, we will deal with what rational numbers are, what irrational numbers are, and how to prove, and so on. Let us see. Now, coming to rational numbers. What are rational numbers? Simple. The numbers which can be expressed in the form of p by q, where q is not equal to 0, are called rational numbers. And what about p and q? P and q are integers. P and q are integers, but q is not equal to 0. This is very, very important. Please don't forget, the definition says the numbers that can be expressed, not that the numbers that are in the form of. So only those numbers that can be expressed in the form of p by q, not that every number, every rational number be in the form of p by q. Please remember. So let us see. All natural numbers 1, 2, 3, 4, 5, 6 fall under rational numbers. Whole numbers 0, 1, 2, 3, 4, 5, 6 fall under rational numbers. Integers minus infinity dash 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 minus 4 minus 3 minus 2 minus 1 0 1 2 3 so on are all rational numbers. Besides these, 1 by 2, 2 by 4, 5 by 7, 9 by 10, all these in the form of p by q are rational numbers. And also decimals 0.1, 10.5, 3.9, all these are rational numbers. And there are also other kind of decimals like 1.3333333 so on, 2.5555555 so on. All these are called rational numbers. The natural numbers, the whole numbers, the integers, the fractions, the decimals, the repeating decimals, all these come under rational numbers. So when we know about all of these, we must be able to write this p by q form into decimal form and this decimal form into p by q form. Though this is learnt at earlier stages, please let me make a short note of this. When you have a fraction and you're asked to find its decimal form, what do you have to do? You divide the numerator by the denominator and you will get something like this. So decimal point 2 5s are 10. So this 1 by 2 is equivalent to 0.5. This is decimal form and this is p by q form. So to convert a fraction into decimal form, you have to divide the numerator by the denominator. When you're converting a p by q form into decimal form, there may arise different cases. So for example, if you take any number like 3, whatever it is, and go on dividing it by 1, 2, 3, 4, 5, 6, so on, so on, so on, so on. If you go on dividing them, for example, let us take 3. If you go on dividing it, you get 3 types of results. Sometimes it is completely divisible like here. So if you are dividing it by 1, 1 3s are 3, so it's completely divisible. The quotient is 3. Therefore, 3 by 1 is equal to 3. This is one type where you will not get any decimal at all. So for example, if you are dividing the same 3 by 2, the next one, 2 1s are 2, 1, 2 5s are 10. So you might also get sometimes the decimal. So 3 by 2 is equal to 1.5. But the same, if you divide by 9, let us see what happens. 9 zeros 0, 3 remains 0.0. 9 3s are 27, 3 remains. 9 3s are 27, 3 remains. 9 3s are 27. So on, if you go on doing, you will end up in getting a decimal that does not terminate. So 3 by 9 is equal to 0.3333 and so on. See, when you are dividing any number, we arrive at 3 situations. One situation where it is an integer. one situation where it is a decimal, which is terminating, one situation where it is a decimal and not terminating but repeating, non-terminating and repeating. So all these can be the chances when you convert a fraction into a decimal form. Now, can we convert a decimal form into p by q form? Definitely. So how to convert this one into this form? Simple. When you have an integer, to convert it into p by q form, simply write by 1. That itself is the answer. Because all we need is p by q form and p and q must be integers. That's it. Achieved. No problem. For example, if it is 1.25, how can we convert it into a fraction? Let us see. You have to multiply it by some fraction, because you have to make it a fraction, multiply it by a fraction. Why? What fraction? And if you multiply, its value may also change. Then what to do? Yes, but we have our friend multiplicative identity, which does not change any value. So multiply it by 1. Sir, you said fraction. Okay, let it be 1 by 1. But multiplying it by 1 by 1 does not make it a rational number, because in a rational number, p and q both should be integers. Now if I multiply this one, 1.25 into 1, it becomes 1.25 by 1. But this is not p by q form, because here this is not an integer. Integers do not have decimal points, please remember. So then what to do here? So this, instead of putting it like this, we can do one thing. So when you are multiplying it 1.25 into 1 by 1, what can we do to eliminate this decimal point? What I say is, every number has a decimal point. Sometimes seen, sometimes not seen, sometimes read, sometimes not read. How? Let us see. For example, if you have a number 5, you should understand that the decimal point is at the ending, because you can't see it anywhere. If you have a number 247, there's no decimal point, means you should understand that the decimal point is here. Please mind this one. And sometimes we also have 2.47. So here the decimal point is seen and read. Here the decimal point is not seen, not read. But like the air, though not seen, it is there. Like that, though not seen or seen, point is always there. So please remember that. So 247 means it has a decimal point at the ending. Means when it is at the ending, we consider that this point is not at all there, because we don't read it. Yes, sir? Yes. That means here, to make this disappear, what can we do? We can send it to this last point. So we have to send it from here to here. So it has to jump over 2 digits. To jump over 2 digits, it needs 2 zeros to be multiplied with. So if you multiply it by a number having 2 digits, this decimal point automatically jumps here. This is the secret. So you need 2 zeros to jump the decimal point. But if you take 2 zeros and multiply, its value should not change. So you're taking 2 zeros as numerator, 2 zeros as numerator, and 1 here. Why only 1? Because it is easy to multiply by 1. You can also take 200 by 200, 300 by 300. You can do it. And even you can take more number of zeros, 1000 by 1000. It does not create any problem. But to do it the simplest way is our target. So we'll take the minimum number of required zeros and the easiest multiplicative identity 1. So this does our job. Now if you multiply by 100, this 1.25 becomes 125, and 100 is as usual 100, because it has nothing to multiply, maybe 1, so 1 into 100 is 100, and on cancellation we get it as 5 by 4. Therefore the p by q form, which is not equal to 0, of 1.25 is 5 by 4. What did we do? We have to take the number with decimal and multiply it by a fraction which has as many zeros as there are digits after decimal point, and preceded by 1 on the numerator and the denominator. Then you will get the result like this. This is one method of converting a decimal into a fraction. Now, what about this kind of cases? For example, you have something like 1.33333 and so on. In these cases, how do you convert it into P by Q form? Does this apply? Let us see. What is the method? Take the number. Okay, I have taken. Multiply it. Okay. By a fraction with one above and one below. Oh, how many zeros to put? As many as there are digits after decimal in this one. So let us count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can't count. So innumerable number of zeros you have to put. Is it possible? Not possible. We have to end it. So this method doesn't apply to this. So to convert this kind of decimals which are not terminating but repeating, we have a separate method. Let us see. For example, let us see, we have 1.252535353 and so on. This can be written as 2.53 bar because that is coming again and again, so we will use the bar. That means this is being repeated infinite number of times. Now we have to write it in P by Q form. We don't know how to write it in P by Q form because the earlier method is not applicable here. What can we do? Let this be equal to x. So let 1.253 bar be x. Then x is equal to 1.253. Okay, so 53 can be written as 53, 53, 53 and so on. So let us think this is equation number 1. Now we can do one thing. There in the earlier case we multiplied it by a number having as many zeros as there are digits after the decimal point in this. Here it changes. Here we will take the number having as many zeros as there are digits under the bar. Under the bar there are 2 digits, so we will take a number having 2 zeros. So here there are 2 digits, so the number having 2 zeros is 100. So we will multiply this by 100. This means x. So we will multiply equation number 1 by 100. So we say multiplying equation number 1 by 100. So it comes like this. X is equal to 1.2535353 and so on. When you multiply it by 100, you will get something like this. You have to multiply on either side. X into 100 is 100x is equal to, and multiplying this, because it is 1, you will get the same digits, and because of these 2 zeros, you will see that this point jumps here, so it becomes 125.3535353 and so on. Now let this be equation number 2. Then subtract equation number 1 from 2. Subtract 1 from 2. So this becomes like this. 100x is equal to 125.3535353 and so on. Under that you write equation number 1 is equal to 1.2535353 and so on. If you observe carefully, you will get 303, 505, 303, 505 like that. All they disappear. No matter how many infinite digits, no matter how many number of digits are there, let them be infinite number of digits, they all get subtracted 0, 0, 0, 0, 0, 0, 0. So they all get to zeros. Finally this comes out to be 3 minus 2 is 1. Now 5 minus 4, 1 is 4. 2, 1 is equal to, this happens to be 99. You subtract it, okay? So now what we are finding is x, because we want to convert this now. So x is equal to 124.1 by 99. So this is written in the form of P by Q. Is it really the P by Q form? No, because there should not be decimal either here or either here. So it is decimal here, so this is not considered as P by Q form. Then what should we do? We have to change this decimal to here. What to do further? We will multiply it by 10. So multiply it by 10 by 10. Why? because if you multiply it by 10 by 10, 10 by 10 is nothing but 1. So when you multiply it by 1, its value does not change. So this becomes 1241 by 990. This is the P by Q form of this. If cancellation is possible, we will go for cancellation. If not, we will leave it like that only. Right? So this is the method. But this method appears very laborious. But when asked for 2 marks, you have to follow this method. But if it is asked for half mark or 1 mark, we have a method. What is that? Let us see. So when you are converting 1.253 bar into P by Q form, we can do one thing. Write that number completely, ignoring the decimal point and bar. But you should not write them number of times. Whatever are repeated, they have to be written only once. That is, the bar number must be written here. Then from there, you have to subtract the remaining number which is apart from bar. What is the remaining number? 12. So subtract 12. What do you get? 1, 4, 2, 1. Did you get 1, 2, 4, 1? Yes. That you take as numerator divided by. What should you do? Put as many 9s as there are digits under the bar. Under the bar, how many digits are there? 2 digits. So you put 2 9s under the denominator. And if at all there are any digits between decimal point and the bar, how many digits are there between decimal point and bar? 1 digit. The number is 2, but we are speaking of digits. So the digit is 1. So you put 1 0 here. So this is the result of this one. Therefore, you can simply write 1.253 bar as 1241 by 990. If cancellation is possible, we'll definitely do that. So this is about expressing a non-terminating repeating decimal in the form of P by Q. Now, there was an integer, you could convert it into P by Q form. There was a decimal which terminated, that is terminating decimal, which you could convert into P by Q form. There was another decimal, non-terminating but repeating, you could still convert it into decimal form. Now, for example, if you are given like this something 1.23456781214151617181920 like that, it is neither repeating, non-terminating, then what can we do? This cannot be written in P by Q form. Why? Let us see. If you put by 1, because this is not an integer, this is not valid. So if you really want to multiply it by something 1 by 1 and some zeros, you don't know how many digits are there, so that is not possible. And even if you want to follow the other method which we learned, by that also it is not possible, because during subtraction they don't match and it results in a biggest number, which is again an impossible case. So this cannot be written in P by Q form. So this type of numbers which have decimals which are non-terminating and non-repeating, they cannot be written in P by Q form. Hence they are called irrational numbers. Not rational. Irrational means not rational. So what are irrational numbers? That numbers which do not terminate as well as do not repeat. They are called irrational numbers. Where can we find this? Simple. If we have to find out root 2, we only try it up to 1.414. Yes or no? But if you go on doing, your life goes away, but it does not terminate and it does not repeat also. So this kind of root 2, root 3 with a prime number and a root above that. So for example, with a prime number and a root. So these are all called irrational numbers because they give you the decimals which are not terminating and not repeating. So they are called irrational numbers. Now we have to see about irrational numbers. Simple to say, any prime number, if it has a root, that is an irrational number. And if you add any irrational number to an irrational number, then also it will be an irrational number. If you subtract one irrational from the other, also it will become an irrational number. And if you multiply or divide, sometimes it may be rational or irrational, that you might have learnt in 9th class, that is not of matter now. But if you take a rational number and an irrational number, if you add them, if you subtract them, if you multiply them, if you divide them, no matter, always they result in an irrational number. That is the last part of this one, where we have to prove whether it is rational or irrational. That will come across in the problems. Coming to the last part of the chapter, logarithms. Because it is introduced for the first time, most of the students have been feeling this is really tough. But once you understand the gist, it is the simplest of all the topics learned till now. So, what to understand? Simple, just understand the basic. What is the basic you should understand? For example, 3 is multiplied 2 times, we write it as 3 to the power of 2. Now its value is equal to 9. So this one, 3 to the power of 2 is equal to 9, we write. For example, we have 5 multiplied 3 times. 5 into 5 into 5, let it be equal to 125. Now this can be written as 5 cube is equal to 125. This is called exponential form. This is called exponential form. In this we will have a base, we have a power, the exponent, hence the name exponential, and this is the value. So this is one method of expressing repeated product. Now the same, a great scientist called Napier taught it differently. Multiplications and divisions are really complicated. If we can convert them into additions, how easy it would be, he thought. As a result of his thought, we got the new topic called logarithm. When John Napier saw that 3 to the power of 5 into 3 to the power of 2 is equal to 3 to the power of 7, owing to the exponential law, a to the power of m into a to the power of n is equal to a to the power of m plus n, he thought, oh, instead of multiplying such big numbers, how easy it is adding the powers. So if everything could be written in the form of powers, how easy it would be. There would be no multiplication, there would be no division. It's all the world of additions and subtractions, he thought. Therefore, he thought of expressing every number in terms of its power. For example, this one says 3 to the power of 2 is equal to 9. In logarithms, we write it as log 9 to the base 3 is equal to 2. Here, this number is expressed in terms of its power. Now, powers can be added, that is nothing but multiplication. Powers can be subtracted, that is nothing but division. So, in this way, he wanted to express numbers in the form of powers, and that is the name given as logarithm. What do we do in logarithm? What is this? Let us see. When we say log 9 to the base 3 is equal to 2, it has the meaning as follows. The meaning is, if at all you have to get 9, how many times you have to multiply 3 by itself? That is the meaning of log 9 to the base 3. The meaning is, if at all you have to get 9, how many times should you multiply 3 by itself? How many times? 3 into 3, 9. So you have to multiply 2 times. Therefore, the answer is 2. For example, you have a question like log 81 to the base 3. What does it mean? In order to get 81, how many times should you multiply 3 by itself? That is the meaning of log 81 to the base 3. How do we get to this? Simply, you try to do it by prime factorization using this one. So 3 27s, 3 9s and 3 3s. So 3 is multiplied 4 times. So the answer is simple, 4. So this means 4. That means when you put this as power to this, you will get this one. That is the meaning of logarithm. So please concentrate on this. When I say log 1000 to the base 10 What does it mean? It means 3. How many times should you multiply 10 by itself in order to get 1000? 3 times. Obviously, this is the thing. This understanding will give you answer for all the questions that you have in your logarithms. When you get minus, what happens when the power changes, when the base changes, everything you will get the idea when you know it. So please do think in terms of this one. And finally, you should know 3 rules: product rule, quotient rule, power rule. They're very simple. Let us see the rules. The product rule. What does it say? It says log xy to the base a can be written as log x to the base a plus log y to the base a. Simple. The both, instead of being multiplied, you are adding them. That is product rule. The quotient rule says when you have to do log of x by y to the base a, you have to write it as log x to the base a minus log y to the base a. So instead of division, you are doing the subtraction. You are getting one step below the usual method, because from addition comes multiplication, from subtraction comes division. So instead of division, you are getting down a step to do the so-called subtraction. Instead of multiplication, you are getting one step down to do addition. And what if you have to power it? Let us see. That is called power rule. It says log x to the power of m to the base a can be written as m log x to the base a. So this comes here. So we have understood from multiplication comes the power. So now the power is reduced to multiplication. The m is multiplied. Like this, you are getting one step below your standard. That means you can understand it very easily. That is the concept of Napier. We should really praise him and pray to him. If you know these, you will understand everything. In the examination, you may be asked some interesting questions like this. Log 1 to the base 2020. What is its answer? Or log 2020 to the base 2020. Simple. Keep it as x. So what is the answer? If you have to get 1, how many times should you multiply 2020? What power should you keep to 2020 in order to get 1? Simple, 0. Any real number which is not 0, when it is raised to the power 0, you get the value as 1. So its value is simple, 0. And what about this one? How many times should you multiply this one to get this one? Simple, it's 1. And if you have something like log 20 to the base 1 is equal to how much? Most people go on to answer it's 20. It's not that. No matter how many times you multiply 1 by itself, you will not get 20. So it is not defined. That is why in the definition of logarithms, they say this is a real number but not equal to 1. So logarithms are not defined for the base 1. This is very, very important. The remaining things we look into them at the time of doing some problems. Thank you.